Good evening, Jamie. Today is the day that I'm recording this video for you that you've been asking for, this Unreal Engine tutorial. So, what I'm going to show you how to make, Mr. Morris, is I'm going to show you this little drone here, how he's going to shoot lasers at a player, and that player is going to be you, the player. And in the game, you're going to have to pick up little floating orbs that spawn in a big circle. So, in my scene, Jamie, I have just a pretty default scene. I've got big kind of plane here. You can stand on and walk on type shit. Then I've got this little laser right here. This is a blueprint, which basically means it just you can do stuff. You can program it and things like that. And attached to the blueprint, it's just a laser object, just a cylinder, glowy or red. And it's also got this projectile movement component, which will make it shoot in the direction. Now, next we have our drone, which is just a drone mesh. I did not 3D model this myself, but yeah, it's just a pretty cool drone. So again, it's a blueprint, so we'll close that. Then over here we've got BP small spear. There's nothing to this yet, apart from some bits, which I'll explain later. And then we've got the spear spawner, which is going to spawn in this guy. These are all blueprint classes. Now, I've also got some audio. I have this thing. These are 3 different audio files for shooting a laser drone, which I'm not going to bother doing today because it's going to be loud and will hurt your ears. Then I've got this meta sound effect, which is like a better, more powerful sound, which will take these guys and kind of do cool things. Then I've got this attenuation drone thing, which is like far away shit sounds far away and close shit sounds close. Then in FX we have just a little burst visual effect here. Then in game I have another blueprint. It's a different kind of blueprint. This one is blueprint game mode base, which is used for it's used for different things, Jamie. Then in my maps I've called this Adam map, so I know this is my map I'm playing on. Then in static mesh, this is just the 3D models, just the models on their own. So you've got like the drone, the laser, all the materials and textures for those things. And if I go into the drone, we can have a look. There's actually little sockets attached to this, which we'll use later. Rifle left and rifle right, which we're going to use later. So I'll close this for now. So, Jamie, when we play this game, look what happens. We can fly around, do all that good stuff, but it's pretty boring, right? We have a drone, we can hit into the drone, that's about it, not doing anything. So firstly, we want the drone to look at us, right? So let's do that. We obviously have to go into the blueprint class, and then we have our blueprint area. This is where we program the drone. So, how do we start programming? Well, firstly, we need to tell the drone to look at the player, right? So, how do we do that? Well, we do left click and we search for begin. This one. We click on that. Event begin play. This will happen as soon as the actor has spawned in. So, as soon as the drone starts, which is right at the start of the game because he's right here, whatever we attach to this code will happen straight away. So for example, this is the execution pin. If I drag off and I write something like print string, which prints a line of code. String is just a bunch of writing. It will print it to the screen, let's say for 10 seconds. Let's make the print say something like, Jamie is cute. And it will compile this. And then because it's going to happen straight away, we'll see Jamie is cute come up in the top left corner of the screen. There it is. Jamie is cute. And that will go away after 10 seconds because we set the duration to 10. But we don't want it to say that. What we want it to do is find the player. So we don't want to do that in event begin play. What we want to do is set the rotation and movements inside of our tick function. That's what it's called. So tick, event tick. Similar thing, except here, this code executes every frame rather than just at the start. So here is where we want to obviously, what do we want to do, Jamie? Well, we're gonna add. Oh, Jamie, I can't type for some reason. Okay, add actor rotation. Local or world, Jamie? You have to guess it. The answer is world. I'm not gonna bother explaining why. So we're adding rotation to the drone, but we want to be able to say this drone should find the player, right? We don't want to just make him look around randomly. So how do we do that? Well, firstly, we need to get a reference to the player. Now the player, as soon as you spawn in, isn't an actor. It's not a blueprint. It's called a pawn. So that's just how Unreal Engine works. The default character, once you spawn in, is a pawn. So if I go here, blueprint class, you have a pawn. That's what can be possessed and received input from a controller, which is what we're doing when we play the game. So it's still a blueprint, but it's a pawn. So how do we do that? Well, the player isn't alive at first, Mr. Jamie Morris. You see, the player is not non-existent at the start of the game. That's in, well, right now it's non-existent, but once you start the game, bang, he spawns in. So we can't get a reference and write it in the code because he's not there yet. So we need to use the code to find him. We can do that in when we can play. If we go get all actors of class and we'll search for pawn. Bang. Now, once the game begins, it's going to go through the whole level. It's going to find all the actors that are pawns, which in our level, there's only one, and that's the main player. So we go over here, and we need to say, out of the actors you find that are pawns, we want to say get a copy. And then with this little output here, we want to say promote to a variable. Excuse me, it's a quick cough. So now we're promoting it to a player pawn. So we're saying whatever you get, turn it into a variable. Jamie, I don't know why you're making me laugh. Anyway, turn it into a variable. That'll be. Don't worry, Jamie, I'll cut this bit out. A variable that we can use inside of our inside of our code. Okay, so we want to make sure. It's not even funny. It's not even funny. We want to make sure that this. We want to make sure that this pawn is actually a real thing that the game is finding, right? Otherwise, the game is just going to go crazy. And we can do that by saying is valid index. So it will take index number 0, the first thing it finds, the first pawn it finds, and it will say, is it valid? Meaning, is it like alive? Is it really there? And it will, yeah, it will give a output of a boolean, which is a data type that can either be true or false. So it's saying if this is a valid index, which we know it will be, set this boolean to true. So then we can hold B and right click. That will give us a branch, which we can then connect the boolean into the condition. So this is going to be set to true. So we want to say if it's true, set this player pawn as what you find. So what this code does, we'll look over. At the start of the game, it gets all the actors of a certain class, that class being pawn, and it's deciding is 0 is the first one we find actually a valid index, is it a real thing? If so, make that thing a variable that we can use elsewhere, which we've called player pawn, and only if that's true. Now, what next? Now, Jamie Morris, what do we do next? Well, we have our player pawn variable. That's fine. It's been found inside of the level. Now, we need to set the rotation of the actor, which is the drone, to the player. So how do we do that, Mr. Morris? Well, quite easy. Now that we have our player pawn, we can click hold control and drag this guy here. Boom! We have a reference to our player pawn, which is what's being found up here, which is the main player of the game. So, what do we want to do with this? Well, we want to obviously find the location of it, so the drone can look towards it. However, right now with rotation, we can't really do much, so we need to say find look at rotation. And this gives us a vector, which is just... Apologies for the quick break there, Jamie. I heard a noise outside. I don't know what it was. Sounded a bit like a demon. Anyway, now that we have find look at rotation, that takes a vector as the start rotation and a vector as the target rotation. We can grab this guy and we can say get. I don't know why it sometimes doesn't let me type. Get actor location. Bang. And it returns the same value type because it's yellow. That's here. So we want the guy to look at that rotation. But where do we want the start value? Well, it's just the normal get actor location. Plug that in. So, bang. What this does, every single frame, well, not yet, we need to plug that in. Then drag this guy, make it look nice and neat. Every single frame that this drone is alive, existing in the level, we want to add rotation to the drone using the find look at rotation node. So the first value, every frame, will be the normal location of the target, of the drone itself. He's just going to be looking wherever he's already looking, and the target location is wherever our player pawn is. So if we play the game, the drone is doing that. I can't say I know why, but that's okay. Let's go over here and search for something else. Interp. Interp 2. Now what this does, Jamie, this makes it a more smooth transition. So instead of the drone just slowly looking at you, which right now he's not doing. Can't say why. Hold on a sec. Give me a minute, Jamie. So Jamie, you might hear a cat in the background. That would be because there's a cat in the room right now. So the mistake I made is actually getting the actor's location instead of rotation. So if we go get actor rotation, and then go here, that's still not correct. Jamie, I don't know what's going on. So Jamie, I realized the mistake. Instead of adding to the rotation, we instead want to set the rotation. So we go actor rotation. Because we're not adding to it, we're actually setting it every frame. Then go here, back. Now, if we play our game, he's looking at us no matter where we go. But that's quite strange, isn't it? What kind of drone has that perfect position and movements? That's not realistic. So we want it to be a more smooth transition of the rotations. So how do we do that? Well, we use this node here. It's called interp2. Interp meaning interpolation, which just usually means a smoother transition with whatever is happening. So we're going to go here. We're going to get the return value and then plug it in here. So this is the new rotation that we want to set every frame. So we can already use this code, which finds the current location and makes the new rotation the target. So we can say that's the target. And the current, we can just use our current get actor rotation, because that's just going to return the normal rotation that it's currently at. So we can go here, bang. Now we have two more things to fill out. We've got this bit down here, delta time and interp speed. Now, delta time is just, well, it says there, cat's going crazy on the floor right now. Time since last tick. Now, this is strange But all we need to do is find delta seconds up here and return it there. Now, this node is going to be working in seconds, which is a weird concept, but in games that happens a lot, so don't worry too much about that. Interrupt speed, how quick do we want this guy to move? Let's say, for example, 4. And now, if we compile, you always have to compile to save a script or save a blueprint. Go back, play the game. Now he's looking at us more smooth. You see that? It takes a while to look at us. Very nice. I also don't like, though, how he's looking at me straight away. I think it would be cool if I had like 2 seconds and then he starts looking at me. You understand me, Jamie? So, we can go up here to our event begin play, and let's just add a delay and say 2 seconds. So now, event begin play will start running, and we'll get this delay for 2 seconds, and then continue to get all the actors. So now if we compile and play the game, he can't find me, and now he finds me after 2 seconds. However, we got loads of errors. Now, Jamie, why do you think we got loads of errors? Why do you think that is, Jamie? Well, I'll tell you why. It's because we're telling every frame our drone to look at the player, but we're only telling the script what the player is after 2 seconds. So for those whole 2 minutes, every single frame, or seconds, every single frame is like, yo, what's going on? I can't find the drone. I can't find the player. What's happening? So, easy fix, Mr. Morris. We can go to our event tick here, where we're calling the rotation to be set. We can get a reference to this guy. Then we can right click on it. Oh, just spat on the screen. Fuck. Or left click even. Nope, I mean right click. And then we can go convert to validated get. And then we plug him in there. And we go, if it's valid, then set the rotation. If not valid, just don't do anything. Just chill out. You don't need to give us any errors or anything. Just relax. Then we go back, we play our game. Then he looks at us after 2 seconds and we back out, and no errors. That's because when the code can't find the drone, nothing happens. It's just chill out. Nothing happens at all. So that's our drone done. Very nice. Now, what do we want to do next, Mr. Morris? Well, I would like our drone to actually move towards us. Because the drone isn't very intimidating, right? He's just there. He's just looking at us. But however, if he moves towards us, that would be quite scary. So how do we do that, Mr. Morris? Can you guess? Well, it's a similar thing to what we've done here. We can go over here, we can go add actor. We want world offset. Bang. So, with this node, we're going to get the actors, well, we're going to tell the actor to go in a direction. That's why we're adding the world offset. But right now, nothing's going to happen. We might get an error. We don't get an error on the script, but nothing's going to happen because we haven't given this node enough information. So delta location is where we want this drone to move to. So right now, if I go, say for example, forward, get forward vector, or we'll say for now, just this one, forward vector. Now it might move just very slowly in a direction, after 2 seconds, of course. So there it moves, very, very slowly. But this is the forward vector at the very start of the game. So as you can see, it's just 1, 0, 0. So it's just moving forward. We don't want that. We've already set the rotation to change. So we want to go get actor. What did I just search? Forward. Get actor forward vector. So now this is constantly the forward direction. So he's going to move where he's looking, where his new forward is. See, he's coming closer towards me. But he's a bit slow, right? Which is annoying and boring. So how do we change that? Well, we've got the maths happening here to add the world offset. But we want to just multiply that by something. However, if I promote this to a variable, well, first I'll change it to a float, which means it's just a single kind of number. And then I'll right click and promote to a variable. We'll go move speed and compile that. Then go bang, and we'll make it something like, say, 250. So that's going to make the actor move forward in its forward direction, and then we're going to times that speed by 250. So let's see how quick he moves now. He's still a bit slow. So what we can do is make this something like 1000. It'll move quicker now. Never mind, he doesn't. But that's okay. The reason why, I've just realized, is because I didn't connect the new value to that speed, to the location. So I'm going to change this back to 250 because it's probably fine. Compile. And now he'll move quicker. Oh, move very. Oh, okay. So he's moving a bit too fast, in my personal opinion. So what we can do is, well, make this something like 10 and compile. Let's have a look. There he goes. And he's chasing after me all the time. No matter what, he's chasing after me. He's a bit quick though, I don't like that. So let's say something like 2. Then we'll compile and have a look. That's more like it. He's just slowly following after me. Now Jamie, this is all fine. However, there's one problem. When someone plays the game, this game here, on let's say a DS, the DS is running at what, 20 frames per second? What this code is doing is moving the actor forward by its forward direction times by 2 every single frame. So if someone's playing on something like a DS, it's 20 frames per second, this guy's going to be moving really slowly. However, if someone's playing on like a PC and it's like 160 frames per second, this guy's going to be happening 160 times compared to 20 times, so he'll be moving faster, which is a big problem, right? We don't want the game to play different depending on what console you're on. So how do we fix that, Mr. Jamie? Well, I'll show you. We want our move speed here to be times by seconds, not be based on frames. So we'll go here, we'll go multiply, and then we want to extend this guy out and say get world delta seconds, which just means normal seconds that the game is running. So we can then plug this guy up here. Now what we're doing is we're saying move forward in the forward direction times by move speed, which is being times by seconds. So now whatever speed he moves now is going to happen no matter what console you're on, whether you're on your phone, whether you're on PC, whether you're playing like I don't know, whatever you're playing, and back. He will always move that speed, which is very nice. So that's cool and everything. However, you'll notice he's not doing much, right, Jamie? He's just kind of following us, and he doesn't really kill us. Even if he catches us, he's just there now, which is a bit annoying. It'd be cool if he could shoot at us, which is what we're going to do now with our blaster beam. So let's go to our drone, and let's set it up here, up in our event begin play. After this code has been executed, we want to do this. So what we do is set timer by event. So what this is going to do is whatever we tell this node to do, because I've just enabled looping, it will happen once every 2 seconds. But we need to build an event to happen, right? So this is why we have this event. So we come out and we'll run our own custom event. And then we'll go shoot event. Bang. Lovely. So what do we want our shoot event to do, Jamie? Well, we wanted to shoot the blaster beam, right? However, we can't just, magically make it do that. We need to program it, obviously. So I'm going to make a new programming graph for that, because this is getting a bit ugly now. This is getting a bit much. So what I can do is go to functions, and I can click plus, and we get a new event graph, which I'll call shoot. So what do we want to happen in shoot? Well, we want to spawn a blaster beam, which is the guy back here I showed you. So we can do that very easily by dragging off and saying spawn actor from class, because we're spawning something. So we go bp underscore blaster beam, Very nice. So the problem with this code is, if I try and compile, it's going to throw up an error because we haven't given much information. We haven't told it where to spawn, we're just telling it to spawn in. So where do we want it to spawn, Jamie? Well, let's go socket transform. Oh. So we want to get socket transform from our drone mesh. Let me show you what that means. I showed you earlier. Let me show you again. If I go back to our static mesh, the 3D models, and we open our drone, we have the left and right sockets. And these are the areas where I want to spawn the blaster beam. So we'll close that. And all we need to do is, well, I'm going to right click on this, click, oh, cat's back, click, split that open. The rotation connects up to the rotation, location, the rotation to rotation. It's being quite loud right now, that's okay. So scale we don't need to mess with because, you know, it's always going to be the same size. Then we compile and it's all happy. We're shooting the blaster beam at the location of the socket. However, we have a left and right socket, right? So what do we need to do there? Well, we need to say the socket name. However, when I'm back in my event graph, I want that socket name to be something I can control over here in the main event graph, not over here in the secondary shoot event graph. So how can I do that? Well, if I click my original node here, and I go to input, I can click plus, and then I'll name this guy socket name. And I don't want it to be a boolean because it's a true and false kind of thing. We want it to be a name. Bang. And then we'll see here we have this extra thing here which we can plug into that thing. We'll just move these over. Cat's on the table now. Hopefully it doesn't start meowing, that'll be a bit loud. So now if I go back to my event graph and I call this function, which is shoot, we have this socket name variable, which we have a left and right socket. So let's make variables for them. We'll go here, we'll go socket left, then we'll go name. Cat is like trying to walk on the keyboard right now. Then we want another one for our right socket. So make a variable for our right socket. Now we actually have to call these guys something because right now it's just a variable that is just kind of sitting here, just existing on its own. Cat's trying to drink my coffee now. I should be shaking and shit. Anyway, we do that down here. So the default value right now is nothing, but we want it to be the name of our socket. So we go here. This is obviously rifle underscore L. The other one is rifle underscore R. So let's go back. Let's say socket left is rifle underscore L. Socket right is rifle underscore R. We'll compile. Lovely. Now, Jamie, I'm sure you'll see a problem with this code. The problem is that with this, I'm only going to shoot out of the left rifle every 2 seconds. We can see that in the game. Boom. Boom. See that? That's bad. I also don't like how quick that's going. So let me go back to blueprints. And I'll go to projectile movement and I'll change the initial speed to something like 1000. Okay? Then he's going to shoot the projectiles a bit slower. Sounds a bit quick. Okay, that's very slow. We change it to like 3000. This is just changing the speed of the projectile. That's better. So, as you saw before, he's only shooting from the left projectile because we've told it to only shoot from the left projectile. Bang, left. Bang, left. Bang, left. Which is a problem, right? Because we want him to shoot both sides. So how do we do that? Well, we can use a node called flip flop flip-flop. What this node does is every time it's called, every time this node is triggered, it will execute A, then the next time it will execute B, then A and B and A and B. So we just need to get this guy, copy paste, and in B, change that to that guy. Move these guys over here, grab this guy, put it here. Grab that guy, put it there, and bang. Now if I set it to something like 1, so we can see it quicker, he'll shoot left and right and left and right because of the flip-flop. Easy type shit. So, there's one more thing I want to do here, Mr. Jamie, and that's spawn our little particle effect coming out of the rifles when they're shot. So we can do that here. So once the actor blaster beam has spawned in, we want to say spawn system at location. Now our system is this thing. It's a Niagara system, which is like a burst of particles, like a particle effect. Niagara system, I guess they call it for Niagara Falls because there's like water. So shift this guy over. Now what we need to do is we need to set the location and the rotation. Do the same thing that's here. I mean, what? What? Anyway, so we go back here and we do that thing, and bang, you'll see nothing happens. The reason why is because we haven't set the socket name. So we'll go back over here and plug that guy into there, and now, because it's going from left to right to left to right each time, we'll see. You see the little burst of fire that goes out. It's quite cool, right? Let me check what that looks like in game as well. That's what it looks like. It's just a burst. Just a big burst of shit. Alright. So, that's our drone done. Very good. Now, the game is pretty cool. However, the main problem is, well, these little particles, these things that fly out, they're acting a bit strange now, aren't they, Jamie? So, we can fix that in the Blaster Beam class. So, obviously, like I said before, this class has a mesh component attached to it. Then we'll go to our event graph. What do we want to do, Mr. Jamie? Well, we want to be able to say when that Blaster Beam hits something, it needs to destroy. So how do we do that? Well, we can type hit, and we can say assign on actor hit, and then we have an event. We'll call it hit event, and we want this to happen somehow, because right now this is not being called at all. We'll do it in the begin play. So once the blaster beam is spawned in, it's going to check to see if it hits anything. Once it does hit something, it will call this event. So for now, we can say spawn system at location, just like we did last time. The system is the burst, the beam burst. Now, there's a problem with this, Mr. Morris. The problem is that when our system spawns in, it spawns in randomly. Doesn't know where to, well, it doesn't spawn in randomly, it spawns in some weird location. We want it to spawn where our blaster beam hits. So if it hits the ground to the left of the player, we want the effect to happen there. So how do we do that? Well, we have this little output here called hit. If we drag off, we can go, oh, that's weird. We go break hit result, which gives us all this information. So this is the original output, and this is when you break it open into loads of different things. So we can use this. The location or the impact point is where the blaster beam has hit something. So that's where we want the location to spawn, right? Now, rotation is a bit harder, because if we just set it at 0, the system will spawn in, and it will spawn in the direction of 0, 0, 0, which won't always look great. So we need to be able to say, hey, what way is the wall facing, and set that as the rotation. So we can do that with normal. If we go make, I can't type again, make ROT, that means make rotation, and we want to use from X because X is always the forward direction. And then we'll return that as the rotation. And there's one more thing we want to do. After we've spawned this system, we want to destroy actor. Otherwise the blaster beam will just sit there on the ground forever. So let's see what that does. You see that? It disappears and it spawns a little particle effect going upwards because we've said make that the rotation. So that's everything done for now. However, it's not, because we want to be able to say if this blaster beam hits the player, end the game, because that's how you lose. So how do we do that, Mr. Morris? Well, we have our other actor output, so we can drag off and we can say is A, use this guy, and then similar to how we did before, it will look for an object class. So we want to say pawn, scroll down, find just pawn on its own. We only have one pawn in the level. My cat's back. We only have one more pawn in the level, and that's the player. So if this is correct, we want to go hold B, press. If the thing that's being hit is a pawn, meaning our player, if it is true, we want to quit game. That will just end the game as soon as we get hit by a blaster beam. If it's not a player, meaning anything else, then we want to spawn the system at the location. Send this to the branch. So, does it make sense, Jamie? We'll compile this, we'll go here, and we'll watch the drone hits the ground, spawns the system, but if it's me, the game ends. Very cool. Cat's being loud and shit. I'll get head on the screen and shit. So, as I was saying, damn, cat is distracting me right now, Jamie. It's just getting in the way and stuff of your education. Anyway, so hairs everywhere now. So, Mr. Morris, that's how we do that. It's very cool, right? But now the game is a bit boring because there's no objective. You know, you fly around, you dodge these things. It's pretty interesting, but you know, there's nothing to do. So we need something to do. So we've got this small spear. That's what we're going to use next. I'll drag this into our level, bring it up. Now what do we have here? I'm going to explain it to you, Jamie. Here we've got, let me open the whole class, and then we close this one. In our viewport, we have a sphere volume, which is what this strange circle is, this strange ball with lines. This is a collider. We need collision to be able to detect when the player hits this orb. Then below that we have our SM static mesh sphere mesh. What that is this mesh here. Let me show you static mesh. This guy. So it's just a little glowy ball, and that's what the player's going to try and hit in the game. However, right now it's invisible, as you can see, but it's actually not. It's just the scale is 0, which I can't show you right now, unfortunately, and I'll tell you why the scale is 0 afterwards. So here we have our event graph, just like our other event graphs. So what do we want this guy to do, Mr. Morris? We want him to spawn in, and then we want him to chase, or not chase anything, we want him to just kind of float around randomly. So let's do that. Let's say begin play. Right at the start of the game, we won't do anything yet. Let's go tick, and this is every single frame. So every tick we want to add, well, no, we want to set, well, no, we do actually want to add rotation this time. Add actor rotation, world rotation. So, Mr. Morris, you'll see here we're adding the world rotation instead of setting it. The reason why is because I want this guy to always be moving, not just moving like one rotation, go that way, that way, that way. I want him to always be moving. Maybe I'll change my mind later, I don't know. But right now, as you can see, it's kind of just not doing anything. There's not many not many notes here. Jamie, stop making me laugh. There's not many, not many nodes here. So, also, nah, man, not even funny, bro. So, if we go to our event play, we want to make this sphere mesh not invisible. So, how do we do that? Well, we're gonna go here, and we're gonna go set timer by event. Once again, the event is, move this guy down. We want to make our own custom event. I'm going to call this wink in event. Wink in because that's what we're going to make it do. We're going to make it wink into existence. It's not just going to spawn in straight away. It's going to like just like bloop, like a big bloop into existence type shit. I hope that makes sense. So how do we do that? Well, once this is called, I'll put it after 0.1 seconds, so it happens like basically straight away. Once this has been called, we want to add a timeline. We'll call this wink in timeline. Now, just so what this so what this is, Jamie, is if we click on it, we open it up, we have a new page. This is our timeline page. So we want the length of this animation to happen in like 1 second. We need to add a track. So what are these things? What we want is float track. And we're going to call this track scale. Perfect. Now, this is a cool track, but there's nothing happening in it. So what we need to do is we need to add a key to this, which means we'll add a little dot, which is information on our timeline. Right now it's at time 0.3, value 0.1, which is just strange at the moment. Let's make it time 0, so this happens straight away, and let's make this value 0. And then let's add another one, and let's make this time 1 second, value 1. Now if I look at the whole thing, we have this cool graph. If I highlight both of them and right click, we can go to auto interpolation, which you see makes it a more smooth transition rather than just straight across. Compile this guy, that's everything done there. I'm going to close this. Now that information is saved on this timeline. So what do we actually want to do with that information? We can see it goes from time 0 to value 1 to time 1, value 1. But what does that mean? What does that mean, Jamie? We don't know what it means. Right now it's doing nothing. So update is every frame. So every frame we want this guy to, well, what do we want it to do? We want it to set world scale 3D. And we want that to be on scale 3D. And we want that to be on our sphere mesh. Because we don't want to do that on the collider. We want to do it on the sphere mesh. So that's what it's currently doing. However, this doesn't know what to set the scale to. But we can plug it in here. If we break this guy apart, we have the scale X, scale Y, scale Z. And we can just plug that straight in. Now, if I play the game, we'll see how it like spawns in. It slowly gets bigger. That's exactly what we want. That's perfection. Now, I want the same thing to happen over here, Jamie. If we go copy and paste this node, once this timeline has finished, I want to wait 5 seconds. And I basically want to do the opposite to what I've done there, so it disappears. So let's go event, custom, let's go wink out event. Move this guy over. And then what do we want this to do? Well, we want the same thing again. So let's grab a timeline. We'll call this wink out timeline. Let's open it up. We want it to be 1 second long. We'll add our track. We'll make it a float track again. And we'll call it scale. And we'll do the same thing. Make this guy time 0, however this time it's backwards. So it's going to go from a big size, like you, Jamie, to a small size, not like you, Jamie. We'll focus on these guys. We'll go auto, and bang. Now we have our wink out timeline done. And we'll do the exact same thing here. So our update is going to update the scale. And then we're going to plug the scales into the scales. Bang, that's everything done. But it's not, because after it's gone, we want to destroy the actor. After 5 seconds, the actor disappears. It slowly fades out, then it gets destroyed. So it's gone. The player missed it. Now, Mr. Morris, what do we need after this? Well, we need to set the rotation, right? Because we just left this before. I don't know why you did that, Jamie. So, how do we do this, Mr. Morris? So, if we go random rotate, can't type again. Random rotator. This gives an X, Y, Z for the rotation of the pitch, yaw, and whatever the other one is called. And then it's going to plug this into here. However, there will be a problem. If we look, it's spinning really, really, really fast. Right? We don't want that. So, how do we fix this? Well, we can multiply it by a backwards amount. So let's say you have the number 10 and you multiply it by like 0.5, it's now 5. We're multiplying it backwards. So let's go this way. Well, let's just set this to something like 0.05. So whatever the rotation is, it's going to be set backwards. So it'll go a lot slower. Maybe not. So Mr. Morris, give me one moment, please. So Jamie, essentially, let's do the same thing as we did before. Because we know adding the rotation as every frame is problematic. So let's drag out. Let's go multiply again. So we want this to be something like 0.05. And we want this to be something like, well, we want it to be get delta seconds. So we're timesing the seconds by 0.5. Then let's see what happens. It's still moving quick. Jamie, this is a problem. Jamie, silly me. I understood the problem was that I kept this in the delta rotation rather than the new node here. So now let's see what happens. He's randomly rotating. Very great. So that's going to happen every single time we start the game, or every single time that we spawn in the blaster beam. However, we also want to move that guy forward. So we could rewrite all the code, but since we've already done that, there's no point. Let's go to drone. Let's go grab all of these guys, Control C, close that, go here, Control V. We need to redo move speed because that's not a thing anymore in this script. Promote to variable, and we'll call it once again move speed. And let's make that something like 50. So compile that, bring it over here. So now we're doing the exact same thing as we did with the drone. We're adding the world offset. We're making it its forward direction times by move speed times by seconds. So let's go back and see what happens. See how we're slowly moving a little bit? Oh. Okay, yeah. So that's everything perfect. Now, what do we want? Well, actually, no, it's not. I like how slow it's moving. We can use move speed to change the speed. Now he's just flying around, just straight chilling. And after 5 seconds, bloop, disappears. So that's everything here done, Mr. Morris. Let's open this. Let's close this even. And let's go to, well, this is problematic, right? Because there's only one in the whole level. Delete that guy. We don't want that anymore. We want to use a sphere spawner. We want to be able to say, yo, I want something else, a different blueprint actor, to be able to spawn these guys in. So let's open up that. Oh. So here we have everything, right? We have our event graph. So everything's all the programming stuff, which is nothing right now. So let's firstly figure out what we want this guy to do. We want a big area to be like a big circle where these guys can spawn in. My cat's back. My cat's back. So how do we do that? Well, we go event tick. We're going to do something called draw debug sphere, or sphere even. Now, this is cool and all, but we need to say get actor location as this area. So now the sphere is going to be drawn at the location of the actor, which we've just placed over here. So if we have a look at that, bang, A nice little circle. That's what draw debug sphere does. Let's go back over here. Now we have our radius. How big do we want the circle to be? Well, let's promote that to a variable so we can control that all the time. Let's call it variable radius max. What is that noise? What the flip? Okay, my cat's going crazy. Let's call this something like 500. And then we'll see the whole thing's bigger. Big circle, big circle. And we end this. Now, that's cool and all, but it's not really doing anything. It's just drawing a big circle. What we're going to do is we're going to begin play. We want to do the same thing as we did before. We want to set timer by event. And we want to make it looping. And we're going to add our own custom event. And we'll call it spawn sphere. I did spell that correctly, okay. Spawn sphere. Oh. So, as you can see, nothing's happening in this code right now, Jamie. Which is problematic, because we want something to happen. So, firstly, if we go spawn actor from class, and go bp underscore small sphere, that's cool and all. However, we need to say the transformation. Get actor transformation. Bang. Now, every 2 seconds, that guy's going to spawn in one of our little circles. There's one. There's two. There's three. You see how they're all going in the same direction? That's kind of bad, right? Let's fix that. Oh. Let's open up this guy. Well, let's break that. Break this guy apart. And get random rotation. Random rotator, and call that into the rotation. And then we want to break this guy. Oh no, we'll just get actor location. We'll set that into the location. And now it will spawn facing a random direction each time. So it goes that way, then it goes that way, then it goes that way, type shit. So you'll see the problem, Jamie, is that the circles are spawning in the very middle every single time, which is not good. Because if I'm having to fly into them, I'm just going to wait around here, go bang, 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 fly into that one, bang, fly into that one. Which is kind of stupid, right? So we need to be able to say, get a random point inside of this sphere. So how are we going to do that? We're going to go to functions. We're going to make a new one. We're going to call it random point in sphere. Now, Jamie, this bit's going to be so confusing. What we want to do firstly is make this guy pure. I'll let you know what that does later. Then we're going to add an output. And our output is going to be vector. Oh, not vector. Vector. Drag this guy over here. Now, what this means is this new function, once we put it into the gremp path, is going to return a new parameter, which we're going to call something like random point. And it's going to be a vector. That's what this random point is. It's a vector. So 3 values, 3 digits. Now, Mr. Jamie, what do we want to do? Well, we want to get random float. Oh, well, random float in range. So it's going to pick a random number between 0 and 0 right now. That's not correct, is it? We want to use our radius max, which is 500, which we set back here when we're drawing the sphere. So the radius is 500. That means this is going to pick a number between 0 and 500. And then what do we want to do? Well, we want to move the sphere spawner in this place direction thing. Basically, let me write it and then it will make sense. So we want to get actor location. This is going to get the location of the actual sphere itself. We want to multiply that by this guy. Oop. So this is problematic, right? Why is it problematic? Because we're not doing it correct is why. We're going to go random rotator, then go forward vector. I'm pressing Q to make these guys line up. That's a nice shortcut there. Q to make it line up. Breaking my keyboard every time I do that. Let me chill with that. Then we go add, boom, bang, bang, and boom. Boop. Alright, so this is our program, or our script done. So let's have a look at what we've done here, Mr. Morris. Oh! So, just move these guys over. It's always nice to keep it nice and neat. So, Mr. Morris, what's happening here? Well, the final thing we're doing is getting a vector, 3 digits, right? What are we doing over here, though? Well, at the very start, we're picking a random rotator. So this is just x, y, z, random numbers for all of them between 0 and 360. Then we're taking that value and making it the forward vector. So this is the forward direction of the small sphere. And then we're saying we want to times that direction by somewhere between 0 and 500. And then we want to plus that by the original location of our actor. And then we want to make that final vector the return node. Let's go back here and we get rid of this bullshit. So we don't want this anymore. We're going to get our random point in sphere and call that the location. And then we play our game. Bang. Bang. Oh, I've been shot. So it spawns in there. Oh man. Give me a minute, Jamie. Spawns in there. Spawns in there. Spawns in there. See how it's spawning in random each time? If you want to know exactly what it's doing, we can draw the debug sphere again. A box. Draw debug. Hello. Why is it not coming up? Arm. Okay, I don't know where it is actually. Draw debug. There, sphere. Okay, stop. Get actor. Get actor location. Damn it, man. Alright, radius max is our radius max. Bang, bang, bang. We'll save that. And then bang, you see how it's working? It's spawning in randomly each time, and it goes in a random direction. That's exactly what we wanted, Mr. Morris. Exactly what we wanted. So, let's quit this. Let's go out of this. We don't want that anymore. Get rid of that. Alright, this is all the code we need there. Bang, we can close this. Oh. But there's one more problem, Mr. Morris. That problem is that... Well, firstly, Jamie, the problem is... You'll see in our small sphere script, nothing is happening when we fly into the sphere itself. Nothing is happening at all, right? The sphere is spawning in and then spawning out. Or despawning, I guess. And over here, we're just setting the rotation and the movement and everything. But what happens if we fly into it? Well, we'll go here, we'll go overlap. And we'll call this overlap event. What this does, Mr. Morris. Don't do that. Nah, chill. So what this does, let me drink my coffee real quick. Shit's getting cold. So what this does is, once there is an event that's called when this actor overlaps something else, we want to call whatever happens here. So let's go. Stop, chill. Relax. So if our other actor is a pawn, like we've done many times before, we want to find just a normal pawn. So if it's a pawn, meaning our player, we set this branch to true. So if it is, we want to do something. If not, do nothing. But we haven't told this, we don't know what we want it to do yet, which is kind of problematic, right? What we want it to do is give us a point if we fly into it. So how do we do that, Mr. Morris? Well, we can go to a different kind of blueprint. We go to our game mode, which I've called Adam game mode. And this is just basically like any other blueprint. However, this does more functions because it's a game mode. So if I go to blueprint class, this is a game mode class. So game mode finds a game is straightforward, all that stuff, including scoring, which is what we're doing now. So we'll open up that guy. And let's make a new function specifically for scoring. Let's call it increment score Q. And we want to have a variable And that variable, what's it going to be, Jamie? If it's the score, the variable is going to be a number, right? An integer. An integer, which is just a whole number, not like a float where it can have like a decimal place. An integer is just a number on its own. If I go like 2.1, it rounds it to 2 because it can't be 2.1 because it's an integer, not a float. So we're going to go here, we're going to go, I can chill slapping my keyboard. We do that, what's that? I just wanted something random. Let's go here, plus, increment int, not float, because we're working with ints at the moment. So what this node does is it adds 1 to the specified value, then sets it, which it says there. We want to add 1 to our score. Now, this is problematic, Jamie, because it's adding 1 but then doing nothing. We want to print string. Need to chill doing that. So right now it's going to print string, but the string just says hello, so it's a bit strange, right? Well, so it goes away in 2 seconds. Let's make it like 5 seconds. So this, we don't want it to just print hello. That's kind of weird. Every time you score a point, it just says hello on the screen. Like, what is that? We want it to do something else. So let's search for a new node called append, and we want the string version of append, which gives A and B and then returns a string. That's going to be our string. So we'll call A Jamie's points, and then remember to add a space bar, enter, and then B is going to be what's returned here. So let's say initially our score is 0 because that's what it is at first. Oh, no, not 2. Our score is 0. What this code is going to do, every time this is called, is it's going to add 1 to score, and then it's going to print some message onto the screen. That message is going to be Jamie's points, and then whatever the new number is. So let's see how this works. Right now it won't work because we haven't told it, we haven't said to happen anywhere, right? We want to do that in BP small split. So, Mr. Morris, how do we do that? What's this? This event graph seems a bit small. Oh, it's the wrong one. Okay. So, if it's a player, if the thing being overlapped is a player, true, we want to be able to say increment score. But if I try increment score, nothing's there, right? Because it's a whole different script, which is why we need to do something else. We need to get game mode. Let me chill. Get game mode will do exactly what it says there. It's going to get the game mode. The return mode is BP underscore Adam game mode. So now we're saying find this game mode. We're telling it this is the game mode. Now from that game mode we can go in the score. Bah. And the target for this isn't self because self is this blueprint sphere. It's this guy. So the only thing we want to do after that is wink out event, which we've called earlier. And if that's true, this all should happen. So let's take a look at what we've just done, Jamie. Let's say an actor overlaps our small sphere. It calls in this event, which then says if the thing overlapping the sphere is a pawn, meaning a player, if it's true, make something happen from this game mode. And the thing we want to make happen is the increment score. And then after that, we want to wink the sphere. We want to wink the sphere out. So if it's not the player, don't do anything because we don't care. We only care if it's the player. So we'll leave that blank. Now, Jamie, there's one more problem here. If I play the game, our drone's gonna. Oh, what was that? Okay, we can go bang, boom. Jamie's points 1, Jamie's points 2, Jamie's points 3, Jamie's points 4. However, there's a problem, Jamie. Let's say I'm a professional player and I fly into the same sphere twice. What's going to happen? We're going to get 2 points for that one sphere. We don't want that, Mr. Morris. So, tell me, what do you think? How do we fix that? Well, we can add a variable and call it scored. I don't know why that's so much fun. Scored is a true or false boolean. It's a data type. So right now it's set to false because initially it's gonna be it's gonna be false, right, Jimmy? Like, oh, let me lock in. Let me lock in. Um, so that's problematic, in my opinion. No, no, it's not. I'm chatting shit now. We want to use this boolean to only call increment score if it has been set to true, and if not, don't do it, or the other way around. I don't know. Let me write the script and it'll make sense. So here we've got. Okay, all right. So okay, all right. Okay, let me chill. So over here, we want to be able to say once again, only increment score if this thing has been set to true. So let's go hold B, right click, left click even, and then so if the thing being collided is a player, make this branch happen. And this branch is gonna read to check if scoring is true. Bah! So number one branch, as in condition, is check if it's a player, then check if scored is false. If scored is false, boom, make this thing happen. However, this is problematic because scoring is always false. It never gets set to true. So what's the point of having this? Well, Mr. Morris, if you were wondering that, I have the answer. I'm going to hold Alt and grab this guy, and then it gives us a set. Instead of just a get, it gives us a set. So we want to set this guy to true, and then make this thing happen. So this way, if I fly into the same one twice, well, let's look. I fly into it once, it's a player, it's me, yeah, whatever. If scored is false, which it defaults is, set scored to true and make this stuff happen. Then if I go back and fly into it again, it's going to say, okay, is it a player? Yes, it is. Is scoring false? No, it's not. Scoring is true because I just said it here. It's already happened. So now that it's true, it's going to be like, nope, don't do anything. So we compile, we play the game, and let's look around. We have up here, boom, boom. Oh, I'm not collecting it. There. Oh, I died. So that's the whole game done, Jamie. Now, there's a couple of things we can change if we want. So say, for example, we want the uh, the shoot to happen even quicker. We can go up here and we can say something like 0.1, but that's going to be crazy. My computer might blow up here, Jamie. Let's hope not. He's going to shoot me every 0.1 seconds. Oh, that makes the game a lot harder, as you can see. Oh, and I'm dead. However, that's probably too hard. So we can give it like 0.5 or something. And now, boom. The only other thing you really can do is get your spear spawner. Change the max radius to an even bigger amount. Oh. Oh. And then we'll go back to this. I'm going to move this guy like up a bit because that's quite a big difference. I didn't want to spawn two. Move that guy up a bit. Play the game. Fly up to it. Where is it? Somewhere up here. And now we have a big area where our spheres can spawn in. They'll spawn in randomly in this big invisible circle, which I can't see right now. Every 5 seconds it disappears. If I fly into it, Jamie's points equals 1. Jamie's points equals 2. Jamie's points equals 3. And if I get hit, which is quite hard to do to be fair, I die. So, Jamie, that's the end of this. That's the end of the tutorial. I hope you enjoyed. I hope you learned a lot about blueprints and Unreal Engine. Jamie, if you want another tutorial, just let me know and I'll be there. Thank you very much for watching.